Nice to meet you all. My name's Iman. I'm a senior engineer at Ramboll, based in London and Southampton in the UK. So this is the agenda, but first of all, we've had lots of introductions, but you all haven't introduced yourself to us. So we're going to do some fun physical activity to start off with. So we're not going to do a 5K, don't worry, that comes later. I'm just going to get you to stand up or sit down based on certain questions. So if you come from the architecture space or architecture background, do you want to stand up? And then if you're at the back, just stand up higher on your tippy toes. Okay, wow, that is a lot of architects. Okay, you can sit down. And then anyone from a engineering background, do you want to stand up? Yeah, engineers, I love you guys. And finally, anyone from a software background? Nice. Love to see the developers in the house. And then finally, anybody who doesn't fit into one of those buckets? Send down, yes. Nice to meet you all. So today I'm going to talk about Soufflé and Speckle. So I'll just take you through the story of this project and how we ended up with the solution that we came up with. Talk a bit about the workflow, do a demo, and then talk a bit about the future. So this was a slide I added 5 minutes ago because everyone was talking about their company, so I thought I had to get a map as well. So I work for Ramboll. We are headquartered in Denmark, a Danish company, but we have offices all over the world. So a lot in Europe, India, North America. I work in the transport sector, so we're primarily the Nordics, UK, Germany, and India. So around 18,000 people or so, and around 2,000-ish, I think, in the UK. And then a bit of an introduction to the team that was working on this. So you can see me in the middle. You have just met me. The other two very talented members of this team are Arvis and Lucia. So they're both based in Copenhagen in our head office in the Bridges department. And then a bit of background on the project. So this was a wastewater plant where they had lots of truss bridges that were going across and carrying pipes. And the existing workflow that we were looking at for the preliminary design stage was quite manual with a lot of copy pasting of information. And we also had lots of different types of truss bridges, so different heights, different widths, different spans, even different truss types as well. So it was quite a lot of variety, but also very similar structures. So when we first saw this, a light bulb went off in our head and we thought, mango, which is a delicious fruit, but also a suite of software that we developed a long time ago. So this was probably 2016, 2017 time. So it's a suite of custom software designed by Ramboll to design motorway gantries in the UK. So it was a very successful piece of software. So we ended up designing 95% of gantries in the UK between 2015 and 2020. And we thought it'd be foolish to waste all this knowledge about truss bridges. And then Mango is made up of 3 different parts. And I think it was Royal Haskining a little bit earlier. You said naming is a big part of it. And yes, we spend too much time naming things. So we have Sorbet, which handles sort of data management of our product suite. Then we have Smoothie, which does the geometry generation. So that's in advanced steel. And then we have Soufflé, which is for the structural analysis. And I do like soufflés, and this is what we wanted to use in our project. We wanted to take the existing value. So Soufflé has all the calculations. It has the connections to the FEA software, so Autodesk Robot. It will produce the reports for you in a nice, transparent way, so engineers can open it, have a look, and understand what exactly is happening. And an important part inside Soufflé was something else called Coco, which is also nice. So Coco is our internal code library. So it's designed to be neutral. It's designed to work with the Eurocode. So it's got a bit of Eurocode 2 and Eurocode 3 in there for steel and concrete, but also adapt for different national annexes. And then, so we have lots of trusses that we have to design. And the workflow that we were thinking of was, we'll handle our geometry probably in Grasshopper to enable rapid optioneering. And we also need to get that information to our drawings, but we also need to do the analysis of the design in FEA, and we need to do that quickly. So I hear you ask, how can we get all these different things to speak to each other? And the answer, dramatic reveal, is Speckle. Cue shocks and a gasp from the audience. So in our case, the geometry is driving everything. So we chose to use Grasshopper because that's what the engineers liked using and they enjoyed using, which is a very important point. We don't think enough about joy in the design process. We think about efficiency, but it's important that people enjoy what they're doing. So Lucia, who was doing the designing, she wanted to work in Grasshopper, and then we were going to do the drawings and the BIM model in Revit, and then we were going to use Soufflé, which we mentioned before, to do the analysis for us. So Speckle, the real reason it's powerful in this case is not so much the interoperability. The data extraction was very useful for this project, but it enables you to use the best application for whatever you're doing. It doesn't really matter. You can switch things in and out quite easily, and it avoids you having to lock anything in. So one really interesting thing that came out of this project was I realized that it was possible to switch out Grasshopper entirely because of the way we structured it and design your bridge in Python, which a lot of you may hate, but I think is really, really cool. And then on top of that, the viewer was also very, very useful to check interfaces and also check the raw data to open up the side view, expand things and see what the values are. And to add to that, it allowed us to focus on the engineering rather than the interfaces between different software and allow us to add our value as an engineering consultant and be really good engineers. So that's the Coco and the Soufflé part and work on that section. So the goals for this exploratory sprint were 4. So we wanted to prove that we could do parametric truss generation. We wanted to prove we could adapt Mango. We want to automate the BIM model generation, and we also wanted to collaborate between the disciplines and different softwares as smoothly as possible. So I was going to do a live demo, but I'm a bit of a chicken and Revit wasn't working properly. So I'm just going to show a recording that we made earlier and talk you through it. So this is all in real time-ish. It would be a little bit quicker, but we are talking over this. So this is Lucia sharing the Grasshopper script. So she's created her own sliders in order to change the various geometric functions and also allow us to change different truss types as well. One very interesting thing about this was it changed the way we engineer the process. So essentially the 3 of us were having conversations about the data model. So we were discussing what format should the data be in. And that was very new to me in the engineering process. You don't really have those sort of conversations. So it was very, very refreshing because we were focusing on what mattered at the end of the day. And then I think we're going to zoom into the Speckle button, which is there, and we're going to click send. So this project was summer of 2023, so the Speckle viewer and the website, which you're going to see is a little bit older and out of date. And we were all in different locations. So they were in Copenhagen, I was in Southampton at the time, I think. And once you click that button, it's then instantly available to both Revit and Soufflé. And Soufflé takes about 4 or 5 minutes to run an analysis, but it means you can run through an entire design loop, if you don't check anything, in 5 minutes or so. So the speed helps. And then this is Soufflé, so it's a desktop application from a while ago, but I cannibalized it essentially and just got rid of all the gantry specific stuff, and then hooked that into the Speckle desktop system, so you can see a list of the Speckle streams you have access to, and you're able to then download it and then parse it. So this is me just having a look in the viewer and just making sure everything was okay. So those rectangular bits that you see, that's loading, I believe. So it's sort of a bit of a workaround because we weren't able to just pass the loading information that we needed in straight away, but we created these sort of plane surfaces, and then that says it's 4 kilonewtons, or however much it is. And if we go forward a little bit, then you can see this is, I can't even remember what the name of this 3D viewer is, but it's part of the Soufflé app. It's very, very old, but we wanted to keep it just to make sure we could see everything. And in Soufflé, you're able to manage all the combinations, all of the load cases. This was quite UK specific, but we'll talk a little bit about that later. And then you are able to run it in robots. So I click the run button, and that takes a little while. So then I hand it over to Arvis, who was using Rhino inside Revit, and using the Speckle connectors, he's able to pull exactly the same geometric information down and then build the BIM model, which I'll skip forward to. So we had an existing library of elements, and the data that was stored in each of the lines had the information necessary for Revit to create this model here, but also had the necessary structural information for Soufflé to do its thing. And then I think Arvis is going to show, some basic 2D drawings, and I think we then go back to me. So the analysis is finished. This was a bad bridge. Everything failed. But what it allows us to do is check the members, check the joints, also check the plates, but that's not something that we added, the base plates, but that all the logic and engineering is already there. And then you're also able to export all calculations on every single member that you're working on. So that's here. And again, transparency is very, very important in engineering. Engineers will not trust anything that's a black box, and they will not use it at all. So with this, we're basically putting everything in black and white. You have all of the forces that are coming from robots. Then you have all of the formulas with all of the references where it comes from in Eurocode. So you're able to check the whole thing yourself. And then I think the final thing, no, that's done. But it also allows you to open the robot file yourself and actually take your time and analyze the whole thing. So the future. What we managed to achieve was we managed to get the parametric truss generation down. We managed to adapt Mango and use Soufflé with square hollow sections. And then the next things for us for the geometry was to enable generative truss design. So you saw the, I guess, it's not quite a circle, but 2 lines essentially going from the geometry down. It'd be nice to make it a loop. So start off with the geometry, that goes to Soufflé. Soufflé runs the analysis, fails, go back to step 1, try again, then just let it go over a weekend, work it out itself, and then you come back after the weekend and you have a design there and ready for you. So we'd have to do a little bit to make things more neutral, and Soufflé maybe elevate it to a service. And then analysis, we needed to adapt it to Danish standards, which we didn't have time for in the sprint, and also expand cross-section and joints. And then the drawings and models, automate that even more, so make detailed drawing generation automatic, since it's all quite similar. I guess the other feedback from using Speckle, I got quite intimate with like the code and the Speckle base object, which I really, really like, by the way. So whoever did that in C#, very elegant, nice work. And it made it super, super easy to allow us to decide how we were going to work and what information we needed in order to get everything working together. And the support as well was fantastic. Whenever I ran into a problem, I think I posted a question, and then 11 minutes later I got an answer, and then the next day they pushed a new version of the C# SDK. So yeah, thank you all very, very much for all of your hard work. And that's it. My name is there. There aren't that many Iman Warsames around, so you can find me on LinkedIn. And yeah, any questions?
Iman, really, really cool stuff. And I was really impressed with what Ramboll's done with that Soufflé. It looks like an almost fully fledged design application. Having said that, I wanted to find out what was the reason to specifically use Soufflé and not go directly from Revit into Robot and use that link. And why use Soufflé instead? What was the reason for that, Jeff?
So yeah, that's a good question, thank you. So the reason was we wanted to avoid as much rework as we could, and the Soufflé application, we had spent several years developing that, and there was a lot of engineering logic that was locked in. So what it enabled us to do wasn't just connect with Robot, it allowed us to connect to Robot, it runs the analysis for you, then it processes the results afterwards, which is the important thing, and then produces all of your engineering reports that you can check afterwards.